Today I'm going to look at a composition of functions. So we have f of x is x squared minus 2x minus 4, and g of x is equal to 2x minus 5. What we want to find is we want to find f of g of 2. That translates to we want to take f of g of x of 2. So I want to take the g of x function and I want to plug it into the f of x function. Just like if you had, let's just say, just side example here. Didn't mean to write f of x. To write f of 2. Let's just say it's at f of 2. F of 2 means we're going to take 2 and we're going to plug it in for f anywhere where we see an x. So it'd be 2 times 2 minus 4. So it'd be plugging in 2. What we want to do, instead of plugging in a actual number into the f of x function, we want to take the function g of x and we want to take that and plug it into the f of x. And then when we get that answer, so whatever that comes out to be, then we'll evaluate that new function of 2. So I'm going to take g of x and I'm going to plug it into f of x. So wherever I see an x in f of x, I'm replacing that with the g of x function. This whole function here, 2x minus 5. So I'm going to have 2x minus 5 squared minus 2 times 2x minus 5 minus 4. So I'm replacing x with 2x minus 5 because I'm doing f of g of x. I'm taking g of x and plugging into f, just like how I said, like what if f was, or what if we're doing f of 3, we take 3 and we plug it into the f of x function. But here we're taking a function and plugging it into another function. And then we will evaluate the 2 at the end. So now we have to do a binomial squared, and there's little tricks and formulas and everything for binomial squared, but I prefer to just do a binomial times a binomial when I work this out. My memory is not the strongest, so I typically like to just brute force my way through it. So 2x minus 5 times 2x minus 5. 2x times 2x is 4x squared. 2x times negative 5, so I'm using distributive property twice. 2x times negative 5 is negative 10x. Negative 5 times 2x is negative 10x. And negative 5 times negative 5 is positive 25. 4x squared minus 20x plus 25. So that 2x minus 5 squared comes out to be 4x squared minus 20x plus 25. The problem I have with the squaring a binomial formula is on the spot, it's hard to remember, is it a squared plus 2ab plus b squared, or is it 2a minus? Like, it's hard to just remember that sign. So that's why I don't typically rely on memorization of that formula. I like to just brute force my way and just multiply the binomial times the binomial. And then we're going to distribute negative 2. So negative 2 times 2x is negative 4x. Negative 2 times negative 5 is positive 10. And then we have that minus 4. So I have a couple things that I could clean up before we do the evaluation of f of 2, or plugging in 2 into that. I could combine these like terms right here, 25 plus 10 minus 4, while also combining negative 20x minus 4x. Combine those all together. So let's go ahead and do that. 4x squared is not being touched. Negative 20x minus 4x is negative 24x. 25 plus 10 minus 4, so 25 plus 10 is 35. 35 minus 4 is 31, so plus 31. Then now I want to take 2 and plug it into that. So this was f of g of 2. Now we're plugging in 2 for this. So 4 times 2 squared minus 24 times 2 plus 31. So that's going to be 2 squared, which is 4. So 4 times 4 minus 24 times 2 is 48 plus 31. 16 minus 48 plus 31. Not going to rely on my mental math here on the spot. Getting a little close to my camera. Gives me an answer of negative 1. So in the end, after all of that, we get an answer of negative 1. So again, what I did is I took g and plugged it in to the f of x function. If it was flipped around, if it was g of f of x or g of f like that, then you would be plugging in the f of x function into the g of x. And then whatever that number that they want you to do, f of g of 2, plug in 2. But if it was flipped around, g of f of x, you do f of x into g, and then evaluate 2. So hopefully this helps you out. Composition of functions is typically a pretty tough idea at first, but the more you practice it, the more you get used to the notation, the easier it will get.